For a problem like this, we're trying to determine a value for x such that this is going to be an obtuse triangle. And we're actually looking for the range of values. And we don't have any requirement that x has to be an integer. It can be any kind of real number. So we need to think of the relevant inequalities. So the relevant inequalities are the triangle inequality, which is a plus b has to be greater than c. The two short legs in a triangle have to be greater when they are added together than the long leg. That's true for any triangle. That has to be true. Then for the obtuse one, we look at the Pythagorean theorem and we say, well, for it to be an obtuse triangle, then the two short legs have to be less than, the sum of the two short legs has to be less than, or the sum of the square of the two short legs has to be less than the square of the long leg. So if you notice there, both of those require us to know what are the two short legs in the triangle. Well, this problem, we don't know how long x is. And so we have to make the assumption that it can be the longest leg or it's not the longest leg. So let's start by saying if it's the longest leg, that gives us 8 plus 14 has to be greater than x from the triangle inequality. So we know from this that we get x is less than 22. So we know that has to always be true about x. X cannot be a value of greater than 22. If x is 25, it's not a triangle. Then we do the Pythagorean inequality, which tells me that 8 squared plus 14 squared has to be less than x squared. This is assuming, again, x is the longest side of the triangle. And so 64 plus 196 gives us 260. We take the square root. We don't actually have to worry about doing anything special on the square root because we're just worried about positives. We don't have to flip the sign or anything. And so it's just going to be x is going to have to be greater than the square root of 260. That actually simplifies nicely to 2 square root of 65. So now we've learned x has to be less than 22, but greater than 2 square root of 65. Then we do the exact same thing, but we do it when x is not the longest side. So 14 is the longest side. So 8 plus x is has to be greater than 14. So x has to be greater than 6. And then at the same time, 8 squared plus x squared has to be greater than 14 squared. And so that's actually less than because it's the obtuse. And so that's going to give me x squared has to be less than, well, 196 minus 64 gives us 132. 4 does go into 132 33 times, so we can simplify that when we take the square root. So it's going to give me x has to be less than 2 square root of 33. And so in this case, the obtuse case, it turns out there are two regions where the answer is, and that is if x is greater than 265 and less than 222, or greater than 6. And so the way we do it is we say 6 is greater than x, that's 6 greater than x, but less than 2 square root of 33. That anything inside those would be an obtuse triangle. Or we could have x is greater than 2 square root of 65 from this one. 2 square root of 65. X is greater than that, or it's less than 22. And so that is our answer. Now, I like to think about this on a continuum. It always works this way. The continuum says that the outsides is just the sum and the difference of the two sides that you're given. So 14 minus 8 was 6, and so that's here. 14 plus 8 was 22, so that's there. And then we put these two values in the middle where you get a Pythagorean theorem. And a Pythagorean, not triple, but you solve the Pythagorean theorem. 8, 14, and 2 root 65, that's a right triangle because 8 squared plus 14 squared equals 2 root 65, or equals 260. And so the square root of 2, when you take the square root, 2 root 65. And so that goes here, and then 2 root 33 goes here. And this always works where these two are the right angles. Whatever you need to do the Pythagorean theorem, that's right. In between the smallest and the first right angle is an obtuse triangle. Anything in between the second right angle and the largest value is an obtuse triangle. And anything between the two right angles is an acute. And that just makes it really easy to see what your answer is. Our answer for this one was 6 to 2 root 33 and 2 root 65 to 22.